Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about China's moon mission Chang'e 5. So let's dive right into it. Well, first we have to understand what exactly we are talking about. We are talking about it's a robotic mission for moon sample return. You have to understand that at this point in time, sample return missions are very hot. USA is doing it, Japan is doing it, European Union is pouring a lot of money into this. So at this point in time, it's very hot, and this will be first time China is trying to do that. So be mindful, this is a very big deal for China, and it was launched in 23rd November 2020. So it's not a very old mission, and this was utilizing a rocket of Long March 5. Now, let's understand this mission. Now, this mission was a subcategory of a primary mission, that is China's lunar exploration program, which has been going on from 2003. So think of it this way. There was a major mission in NASA, go to the moon before this decade. That would be classified as major mission, and there would be a lot of minor mission inside it. For example, all the early programs that were like, test out how the heck rocket works, test out how the Apollo project, Gemini projects, those will be sub-projects, quote unquote. So this is exactly like that, a sub-project of a primary project. The primary project is Chinese lunar exploration program that has been going on, like it's going on the background, and it's slowly putting pieces together. Think of it this way, like they have a dedicated goal. It's like we have to reach there, and these are the technology we need to actually achieve that. So they are like, okay, brick by brick they are building. It's a very long game, but they are playing it well, and they had a very unique approach to it. It's like they will always do two missions on every single stage. For example, orbiting missions, they will do two orbiting missions. Landing mission, they will do basically two landing mission, number 3 and number 4. Sample return, they will do 2 of them. 5, we are talking about that. So that was the whole point of it. So even if they had a failure in one stage, they will always have a backup ready immediately. It's like, okay, something bad happened, okay, let's fix it. So it was from day one, it was planned like that from day one. So that's why I'm specifying, you have to understand too, CLEP is the primary goal behind it, not the what you see Chang'e 5. That itself is not important. The important part is China's lunar exploration program. Now this is the 5th in the pipeline, so to say, and this is ludicrously complex. It's a bit over complex, and I will explain why the heck it's so over complex. It has an orbiter, makes sense. It has an ascender, okay. It has a lander, makes sense. It has a re-entry module, obviously, and ascender is the puppy that will basically carry the rock sample from the lander part to the orbiter part. That's the whole point. It's basically like a ferry system. Now let's understand the location of this. Now, thankfully, due to Apollo missions, there have been multiple Apollo missions, and there have been a lot of Russian missions where basically lunar sample return has been already done. So all of these data points give us a lot of information. So what is the unique point of this Chang'e 5? One thing you have to understand, we have a lot more satellites and a lot more remote sensing capability. So at this point in time, the location that was chosen, that was Mons Rimaker in Oceania. I'm sorry, I cannot pronounce that. Luminous. Basically, this exact spot was selected. The sole reason was that with all the data that we have now, like from Apollo, like basically 50 years of data gathering, we have realized some spots on moon, they are very young, quote unquote. They had volcanic activity very recently, quote unquote, only 1.2 billion years ago. Now you may be like, how the heck that's young? To give you a contrast with that, Apollo missions where they landed, most of them are dating to 3.1 billion years to 4.4 billion, basically from Earth's beginning to basically a little bit older. Now, if you have data points from multiple timelines, basically, okay, 1 billion years ago, 2 billion years ago, 3 billion years ago, that's awesome. That's perfect. That's like a gold mine for data sampling. Because if somebody says, okay, land on this Apollo 15 site and collect 5 ton of that, versus land on 15 different places on different times, everybody will choose different time places. Because again, it's not about the quantity of data, it's about the basically how it's spread out through time. So this was a very unique opportunity. That's why, like, it's not just like, oh, some more lunar rock. No, it's a different lunar rock. So at this point in time, if all the data is relayed correctly and all the analysis is correct, this sample should be the youngest at this point in time. Now you may be like, what can we learn from that? Well, think of it this way, we can learn how sun is behaving after a billion or 2 billion years of time. So because lunar soil has no basically shielding from solar radiation, it can actually quote unquote mark the signature. It's like how solar wind is interacting is changing that. Now, if solar wind changes significantly enough, and again, the timeline is big enough where you can notice those changes, you will know, okay, sun is behaving like this in last 2 to 3 billion. That's why this timeline is very critical. The youngest part of it, it's really, really precious. So like everybody wants their hands on this. It's not just like, oh, some more lunar. No, it's unique lunar rock at this point in time. Now let's understand the landing aspect of it. Now this is a very high speed re-entry. They had already done before this. They had already quote unquote tested the capsule, because you have to understand this puppy is going around 11 km plus per second. Now that's ludicrously fast. To give you a context of that, if you compare this to Dragon capsule is specifically designed for basically low Earth orbit. So most likely it will barely able to handle, because those puppies are designed for 8 km per second kind of re-entry. For example, if you took space shuttle, somehow you refueled it in basically low Earth orbit and send it to moon, it can go there, it can even come back, but forget about trying to land. The moment it goes through atmosphere at that velocity, bye bye. And same will happen with basically Dragon also, but the only difference is Dragon is designed reusable, so there is a very good chance it has enough buffer in the heating material, but all of it will be eroded. So basically, forget about reuse. They have to rebuild the heat shield after that. So Apollo had a ludicrously solid heat shield just to maintain that kind of velocity. So this is a very critical aspect. And you can see this capsule. It literally looks like a miniature Apollo capsule. And this puppy so far with all the data points is around 2 kilograms of lunar material has been brought back. Now 2 kilograms is sufficient at this point in time, because China's team is planning to showcase some of it in a museum. So common people, average people, just take a museum ticket and watch and see it. So a lot of noble pursuits at this point in time. Now, one thing you have to understand, China is playing the very long game. Now, USA used to do that when they were like, direct competition with Soviet Union. They had a long game. That's like, before this decade is out, do this. Simple, elegant, absolute goal. So they had a lot of brutal speed to them. They have lost it. After the fall of Soviet Union, they never got like that. Okay, we're gonna do this, like Mars mission. There was never a timeline for that. It's like, they done that? Yes. Could they have done it cheaply? Yes. It's just they never had a timeline. It's like, just do it whenever it's convenient. Right now the moon mission, do it whenever it's convenient. There is no deadline on that. So China is not playing like that. China is like, okay, we're gonna achieve it as soon as possible. So how they are achieving it is basically they have planned to put man on the moon. That's their absolute goal. It's like, do it. And instead of giving a deadline, they are like, as soon as we can do it possibly. So they started that primary project, and in that primary project they are like, just keep doing every single step that we need to verify that we can do this safely, cheaply, efficiently. So this is the whole point. This mission is far more complex. You could have simply had a rocket that goes there, lands completely, the whole rocket lands, and then you have large sample collection and then just come back to Earth. It would have allowed, like, instead of 2 kilo, we may have gone to, let's say, 20 kilograms, and that would be preferable. But why the heck we did not do that? Simple reason: they wanted to test a lot of subsystems that will be utilized in this puppy. For example, this mission is 100% Apollo miniature. So if you follow the Apollo trajectory, it's exactly doing the same thing, and they have to do this exact same thing for lunar missions. So it's one thing to say we think our computers can do lunar landing and lunar reorbiting and redocking, all those things. Another to actually prove it by doing it. So they are doing that. It's like, okay, we think our computers in lunar gravity can talk to each other, calibrate to each other, and then sync up properly without knocking into each other, which you have to understand that was a very critical aspect of Apollo mission. And pilots, basically the space shuttle, I'm saying, basically lunar command module pilots, they had to be specifically trained for that. Don't just ram into it. It's like, it's a very critical and difficult task. So China had to do that, and they had to do it 100% autonomously. So at this point in time, this is a very critical test validation. It's like, we are saying we can do it, to okay, we actually did it. So that's the whole point. This was a very good testing. The lunar sample, that's just cherry on top. The primary thing that they've proven the technology that it works. So they are moving to the next mission, and they're gonna move on. So they have a very surprisingly robust game plan about this. Like, do this, then this. It's a very solid, very robust. So it's make them much more one step closer to actual flight readiness, because be mindful, they already did landing. They already did the landing on the far side. So they are moving along surprisingly quickly, so to say. So their primary target is by 2030, with everything goes according to plan, by 2030 they will have actual lunar human mission. So this was my presentation on China's lunar program. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.